Good afternoon, guys. Whether the gyroscope was done in the last class, in the last lab, Joel, Ransom, Rupine.
Yes, sir.
So gyroscope was done in the last
Yeah,
lab.
sir. Last class it was done, sir.
Uh, okay, guys, shall we start? Am I audible? Karthik? Am I audible? So in today's lab, we'll do an experiment on the governors. So governors are those devices which are used to control your fuel rate based on your speed. That means eventually you're controlling the speed at the end. So governors are those instruments. So if you fix the governor to maintain at 50 RPM, so the governor will control the fuel supply within an IC engine or an EC engine and control that particular speed for you. So this particular thing is done with help of the various forms of governor, starting from the VAT governor, Porter, Proel. So all these governors you have learned in your previous semesters. So in this experimental setup, which is there in your lab, we'll be having two different governors. The one is the Porter, okay. One is the Porter, and the second one is the Hartnell. Okay, the Porter is a dead weight governor. That means Porter acts according to the weight of the thing, and the Hartnell is an inertia governor where it has a spring in it. So if the spring is attached to the governor, then it is a Hartnell governor. If a dead weight is added to the sleeve, then it is a Porter governor. So we'll be calculating the various parameters of the governor, and eventually at the last we'll be trying to plot the graphs of various radiuses, speeds, and your controlling force. We shall see how it could be done. Okay, the procedure. So arrange the setup as a Porter or a Hartnell governor. So all the setup will be there in your laboratory. So if you are given with the experiment of Porter, you need to add a dead weight on the sleeve, which will be prescribed how much dead weight you should add on the sleeve. So that much you have to add it and prepare the governor for its operation. Make proper connections to the motor. There will be a motor eventually already it will be connected. So for the safety purpose, you will be switched it off and then making the governor setup. So once the setup is just done, so what I can do, you can just start your motor using a proper connection. Switch on the control unit and rotate the speed control knob, which is nothing but your thermostat. So this particular thermostat, you have to rotate it, slowly increasing the speed of the governor. Okay, so as and when you increase the speed of the governor, what happens to the central sleeve is, if this is the governor like this, if the speed goes on increasing, what happens to the central sleeve? The central sleeve will raise eventually. So as and when the speed starts increasing, what happens to the central speed? Just write this above. Increase the speed in steps of given suitable sleeve movement. So he'll be giving the sleeve movement for 10 mm, for 20 mm, for 30 mm, because all taken as standards at the count of 10, or even you can take at the count of 5. So it all depends on you. So accordingly, you'll be drawing a graph 10, 20, 30. If you take a count of 5, then it will be 5, 10, 15, and so on. So according to that, you have to increase your speed. Okay. Compute the controlling force for each speed. So you'll be seeing this particular thing in the calculation. How to do it? Compare the theoretical and experimental speeds. Plot the governor characteristics, that is speed versus displacement, and other is control versus force versus radius of the rotation. We shall see how it could be done. So first of all, let us look into Porter governor. Later, we shall discuss about the Hartnell governor. First, initially, we will just discuss about the Porter governor. The Porter governor is a dead weight governor. So here you can see the weights are being added at the center of the sleeve, by which when your governor rotates like this, when your governor rotates, what happens? There will be a centrifugal force pulling this particular thing away, so that your sleeve will be lifted upward. Okay, the sleeve will be lifted upward against the action of your dead weight. Against the action of your dead weight. So this the force distribution is very, very important. So as and when you rotate this, what happens? There will be a centrifugal force away. Because of this centrifugal force and because of the linkages which are provided like this, what happens? the sleeve will be lifted away. The sleeve will be lifted away, but it is against the weight of the governor. It is against the weight of the head weight which is acted upon the sleeve. Okay, so this is how the Proel governor works. Uh, Before going into the calculations, we shall see how the experimental setup looks like. So once the adjustment is being made, you can see a small scale over there. So in that particular scale, you'll be reading out the height of the rise of the governor, the rise of the sleeve of the governor for 10 mm, for 20 mm, 30 and 40 and so on. So you'll be reading that particular reading in this particular scale here. So this will be the Porta Governor. Okay, so since the dead weights are added in the center, you can see very clearly over there. So switch on the motor connection and start the thermostat slowly. So when you start the thermostat, what happens? Your governor starts rotating as such. So your governor is rotating. Slowly increase the speed. So as and when you increase the speed, observe the sleeve of the governor. What happens to the sleeve? Sleeve eventually raises up. So as and when you just rotate, increase the speed, the sleeve of the governor will rise up. So just for the 10 raise of the sleeve, note down what is the speed. For 20 raise of this speed, note down what is the speed. Similarly, go for 30, 40, and 50. So for that particular category of that governor, note down what is the speed. So once you have noted down what is the speed, this is the Hartnell, we shall see it later. Once you have noted down what is the speed, you can go up with the calculation. Now let us see some of the calculations which are involved in the governor. Okay, so I told you, you must take the readings for 10, 20, 30, 40 and 50, the height corresponding what is the speed. So the only reading you will be taking from the governors is the speed. The only reading you will be taking is the speed. So at 10 what was the speed? At 20 what was the speed? At 30 what was the speed? And similarly and so on. So at 10 it was 171, 184, 190, 197 and 207 respectively for 10, 20, 30, 40 and 50. Okay. The weight on the sleeve will remain same. It is 0.718 kg, which is same for all the tanks. Now, each link will be of 125 meters. That will be given you in the form of an observation. Initial height of the governor would be 110. So as in when initial height in the sense when the speed is zero. When the speed is zero, the height of the governor would be 110 mm. But as and when you just increase the speed, what happens to this height? Height gets decreased. Okay, radius of rotation is 135 initially at zero speed. And then when again you increase, what happens to the radius? Radius goes on increasing again. So let us move into the calculations. So height of the governor for every reading, that is 10, 20, 30 and 40 can be calculated as h is equal to h naught into x by 2. Okay, for initial reading 110 is the initial, and height is displacement is 10 mm. So just substitute it, you will get the value of h1. Similarly, you can calculate the value of h2, h3, h4, h5. Correspondingly, substituting the values of 20, 30, 40, and 50 in the place of x. So if you substitute, you get h2, h3, h4, and h5 as 100, 95, 90, and 85. Once that is calculated, next go for the angle of inclination of the arm with respect to the vertical. So that is with respect to the vertical angle of inclination of the arm, you have to calculate. So that is given by alpha is equals to cos inverse of h by l. So cos inverse of h by l in the sense h you have just calculated in the previous step for alpha 1, substitute h1, for alpha 2, substitute h2, for alpha 3, substitute h3, and so on. So for alpha 1, you substitute h1 here, l is already being given in the form of observation. Calculate alpha 1 as 32.85. Similarly, substitute h2, h3, h4, and h5, you will get alpha 2, alpha 3, alpha 4, and alpha 5 as the readings indicated here. Okay. Next, you calculate the radius of rotation, which is r, that is given by 50 plus l into sine alpha. So L would be same for all the cases, but alpha would be changing. If you substitute alpha 1, you'll get R1. If you substitute alpha 2, you'll get R2, and so on. So substituting alpha 1 here, you'll get R1 as 117.8 mm. Similarly, Substitute alpha 2, alpha 3, alpha 4, and alpha 5, you will get R2, R3, R4, and R5 correspondingly. So after this, you have to tabulate all this. So keep this in mind. Angular velocity of the ring. It is just 2 pi n by 60. You know it very well. So substitute n1, n2, n3, and n4, and so on. You'll get omega 1, omega 2, omega 3, and omega 4. So on. Just substitute. They are converting RPM into rats per second. That's it. Okay. Let's come into the centrifugal force or a controlling force. Both remain the same because these are both opposite to each other with the same magnitude. So Fc is equals to m into omega square into r. So m is okay. M is the mass of things you have placed on the sleeve because in order to act it as a governor. Omega you have calculated as omega 1, omega 2, omega 3, omega 4, and omega 5. Similarly, you'll be having R1, R2, R3, and R5. Substitute the corresponding values. You'll get the FC1, FC2. So correspondingly, we'll get FC1, FC2, FC3, FC4, FC5 values. So all the results what you have just calculated, tabulate as such. So first H1, H2, H3, H4, and H5, alpha 1, alpha 2, alpha 3, alpha 4, and alpha 5, R1, R2, R3, R4, and R5, omega 1, omega 2, omega 3, omega 4, and omega 5, and FC1, FC2, FC3, FC4, FC5. So all this results has to be tabulated like this. So whatever your results you have just calculated, just tabulate. So this is your result sheet. So in order to define this data, in order to proclaim this data in a very sensible manner, you need to draw a graph like this. So take a graph sheet. In the first graph, plot speed on the y-axis, sleeve displacement x on the x-axis. You will get a graph like this. Okay, and which is known as a characteristic feature of the governor, is it? So now, on the second graph, what you have to plot, you have to plot radius on the y-axis, the controlling force on the x-axis, then you will get a graph as such. Okay, so these two are the characteristic graphs of the Porter governor. Similarly, you can calculate for the Hartnell governor also. So Hartnell governor, everything remains same with respect to the Porter governor, except the point that at the center here, exactly at the center, there would be a spring like this. In the Porta Governor, what was happening? There was a dead weight which was applied at the center of the governor. Here, there is a spring at the center of the governor. That is the only difference between the Hartnell and the Porta Governor. Rest all the calculations, all the procedures remain the same thing. Okay. Similarly, you can go with vertical height A, B, and R naught is given as 75, 120, 60, and 96. Only 3 readings is enough in case of a Hartnell governor for 10, 20, and 30 mm of sleeve displacement. So what will be the RPM? You have to just note it down, and all the other calculations remains the same thing when it comes to the Hartnell governor also. So just tabulate the results at the end as you have tabulated in the Porta governor. Similarly, draw the graphs of 2 graphs. The one is speed versus light displacement, and the other is the radius and the force of controlling force. So both these graphs you have to draw. This is number 1 and this is number 2. So then your experiment would be completed. So in the examination, do remember that you'll be getting any one of the governor, either Porter or Hackney. So accordingly, you have to set up the governor setup. So that will be, you can see this thing, Hartnell governor in this particular video. If any doubts, you can just discuss, or else we shall move to the attendance. Any doubts, guys? Do you have any doubts? Should we move to the attendance then? So see the Hartnell Governor setup. Slowly she will be increasing the speed as and when you rotate, you can observe that. Okay, meanwhile I'll be taking the attendance. Yes, Bharat is right. Bharat is right. Then with Raj, Manish Dinakar, Mohammed Shamil, Akshay Pradeep, Amal K,
Present, sir.
Hari
Present, sir.
Krishna, Amal K. Okay, fine.
Present, sir.
Hari Krishna. Yes, Hari Krishna. Okay. Next, Prasidh Hegade, Vashin SU, Vashin SU, Akash Pai, Abhijit B,
Present, sir.
Abhijit KC. Okay, Abhijit B is there. B Sheikh B Shetty.
Present, sir.
Okay. Next is Abhishek Bhattji.
Present, sir.
Next is Adarsh PV,
Present, sir. Present.
Aditya S. Acharya, Ajitesh, Akash Shetty,
Present, sir. Present, sir.
Alan Francis. Okay, Akash Shetty is there. Alan Francis, Akshay, Dikshit, Dipayan,
Yes, sir.
Fahim,
Yes, sir. Fahim present.
next is Azim.
Yes, sir. Present.
Azim, how many laps you have absent, man? Only 2 laps. This is the third lap you are coming up.
Sir, sir,
Himawal
I had
Bhaskar.
exam, sir. That time I was didn't present, sir. When I had
Okay.
exam.
Himawal, Jigitesh, Joel,
Present, sir.
Karan Raj,
Present, sir. Present.
Artin T.Y,
Present, sir. Present, sir.
Kiran Kumar,
Present, sir.
Lloyd,
Present, sir.
Manish,
Present, sir.
Vishal, Mohammed Suhail,
Present, sir.
Mohammed Zohaib, I'm not looking into a chat box, man. So please wait. If anyone has missed your attendance, please wait at the end. Okay. Nikhil, Dikshit, sorry, Nikhil Prajwal.
Nikhil, sir.
Yeah, Dikshit, right?
Present, sir.
Okay, Dikshit, I'll mark it. Okay.
Nishchit,
Nikhil,
Nishchit.
Nikhil, yes. Next, Prajwalar, Raghavendra.
Present, sir.
So what is the reason then? Last 5 laps you are absent, Raghavendra?
Sir, because of exams and painting, sir, house was painting that time.
Rakshit,
Present, sir.
Rakshit,
Present, present.
Anton, Royston,
Present, sir.
Lee, Santosh Kumar, Satvik,
Present, sir.
Shafreez,
Sir.
Shafreez,
Sir.
Sheikh Mohammed Dayan, Ransan have marked you. Sheikh Mohammed Dayan, Sharad Kumar, Sharif Ahmed Shibaz, Royston. Have marked you.
Present, sir.
Have marked you, Royston. Sheikh Mohammed Dayan, Sharad Kumar, Shafreez Chico, Shreyas BY, Ajuddin, Vikshit MT, Dinesh S. Katigar, Viraj, Yagnesh,
Present, sir.
Sir, Viraj
G,
present.
Viraj
Sir,
Ahmad.
Rajneesh present.
Okay,
Yes,
Viraj
sir, Viraj
and
present.
Yagnesh Mark. Manish B,
Yes.
Bharat present,
Akshay
sir.
City, Saurav P, Rahul and Krishnan,
Present, sir.
there's Madhusri.
Present, sir.
Okay, Bharat Desrai and Mark. Yes,
Present, sir.
yes, Bharat and Mark here. Okay, that was the experiment
Present, sir.
about government. We should come up with one more experiment in the next week. Okay, till then, have a great week. Enjoy your days.
The previous class couldn't send me a link, sir.
Bharat, yes, man. No. Previous class, why is that? I'll just check. Wait, let me open the calendar of today.
Even today you didn't send, sir.
Yeah, well, I will check it out. Check it out. You most probably your email ID will not be added. Okay. Bharat, yes, right, is it?
Yes, sir.
Give me your email ID in the chat box, Bharat.
Sir,
Yes.
Ajitesh present, sir.
Ajitesh. What's your surname?
70 number
Sir,
0.
Abhijit KC present, sir.
Okay. Where were you
The
when I
email
called
sent.
you?
Sir.
Hello.
Ajitesh, I have marked you, man.
Sir, Abhijit KC present.
Where, this is the first lab of yours, Abhijit Casey.
Yes, sir.
Why, man?
Sir, I don't get mail, sir.
You don't get mail in the sense, have you contacted your class advisor regarding this?
No, sir.
Then, who is responsible for that?
Yeah.
Sir,
You
Alan Franz
missed
is present.
almost all 9 labs, man. Abhijit Casey.
Sir, Alan Franz is
Okay, Bharat
present,
is
sir.
Rai. I'll be just adding it up. Wait. Just a minute. Bharat is Rai. Okay. So just check Bharat S. Rai whether the design lab is being scheduled at every week on this particular time in your calendar, in your Google Calendar. Okay?
Yes, sir.
Just check it. Just check it. Because it has to be scheduled every week, so it should be repeated. Okay?
Sir, Alan Franz.
Alan Francis, yes, man.
Okay.
Yes, what I'm supposed to do, Alan?
Sir, Alan Francis present, sir.
Where were you when I called your name?
Sir, network issue, sir. I didn't heard, sir.
So every time you'll be having a network issue.
Uh,
Okay, fine.
okay,
So it
thank
is
you.
added.
Bharat, have you checked it?
Yes, sir.
Added?
Yes, sir.
Okay.
Hello. Manish here, Manish.
I will not give you the attendance. I'm sorry, you have joined now.
No, sir, that time only I joined, sir.
Then why did you not answer when I called your name?
No, sir, your network can't hear, sir.
ಯಾಕ್ರೋ ಇದೆಲ್ಲ ಮಾಡ್ತೀರಾ ಕರೆಕ್ಟ್ ಟೈಮಿಗೆ ಜಾಯಿನ್ ಆಗಿ ಅಟೆಂಡೆನ್ಸ್ ತಗೊಂಡು ಹೋಗೋದಲ್ಲ
ಅಲ್ಲ ಅದು ಕಟ್ ಕಟ್ ಕೇಳ್ತದೆ.
ಯಾಕೋ ಸುಮ್ಮನೆ ಇವೆಲ್ಲ ಮನುಷ್ಯನ ಸರ್ ಕರೆಕ್ಟಾಗಿ 1:45 ಜಾಯಿನ್ ಆಗಿ ಶುದ್ಧವಾದ ಕ್ಲಾಸ್ ಕೇಳಿ ಅಟೆಂಡೆನ್ಸ್ ಮಾರ್ಕ್ಸ್ ಮಾಡ್ಕೊಂಡು ಹೋಗೋದಲ್ಲ.
ಆಯ್ತಾಯ್ತು.
ಸುಮ್ಮನೆ ನೆಟ್ವರ್ಕ್ ಇಶ್ಯೂ ಅದು ಇದು ಅಂತೆಲ್ಲ ಹೇಳಿ ಬೇಕಾಗಲ್ಲ. US ಹೇಳು.
14ME 072, sir.
Sir, 16ME 131.